Myself Maharaja. My startup name is Purple Hands from Francis Xavier Engineering College. Our project name is Pocketable Sign Language Translator AI based gesture and voice converter for person with hearing and speech impaired. About our idea, Pocketable Sign Language Translator is a bilingual communication system, support both sign to voice and voice to text captioning. Problem progress through the list away. Communication challenge between voice impaired person and a normal person. Individual with voice impaired cannot speak. The result in communication difficulty with other, leading to misunderstanding and social innovation. Just go through with the live practical video section for scenario 1 for this.
Hi, that is the wrong.
Just assume I am a voice impaired person, she is a normal person. Our communication barrier is too long. Step 2. Then the time and date gives us the sign language, but this time the voice impaired knows the sign language, but the opposite normal person did not understand his sign language. Still the communication barrier maintains gaps. Video section for scenario 2. In this scenario, the opposite person did not understand my sign language. Step 3. Attempted solutions like using instruction material. Normal person using instruction material to learn and understand the sign language. However, this process is slow and impractical for real-time conversation, often lead to incomplete or incorrect understanding. It takes more time, like dictionary searching for which word for which sign, which corresponds sign for which word. It takes more time period. It often take to showing and searching the signs, like it take more timeless process. Fine. Just go through the video section for scenario 3. Okay, fine. In this scenario, we are using instruction material with correspondent sign for which word. Act like a dictionary search. Step 4. The sign language translation gap. This is our first prototype. Now we are working in the prototype 3. This prototype 1 is the beginning stage of the idea process. The sign language translation gap. It contains one gap, the weird in the voice impaired person head. The gap contains one camera that detect the hand sign and convert them into the voice. The gap detects the hand sign through the camera, interpret using image processing and machine learning, and converted them into the voice through the speaker. It can easily understand by the normal person. It is the working model of the sign language translation cap. You can able to see the cap contain the camera that detect the hand sign and convert them into the spoken voice through the speaker. You can able to see the laptop, the working process of the sign language translation cap, that's detecting camera showing in the laptop. Just we go through with the video section for scenario 4.
Mouth you can. No fingers detected. Bye bye. Good night. I want to go to restroom. You are so cute. I want water. Bye bye. Good night. I want to go to restroom. Good night. I want water. I will. My name is
In this process, the
Maharaja.
cab detects the hand sign through the camera, interpreted using image processing and machine learning, and convert them into the spoken voice via speaker. So it can be easy to communicate between a deaf and dumb person and a normal person. It is our first prototype. Research done so far. Tested with deaf and dumb students, our product is designed to be user-friendly. We are seeking innovative ideas from regular testing. Just go through the testing video. We tested with the deaf and dumb students. They practice to ourselves with the sign language and interact with ourselves with the sign language.
அவங்க புதுசாக ஒரு ப்ராஜெக்ட் அதனால் உங்களை பார்த்து பேசி புது ப்ராஜெக்ட் கேட்டு எப்படி எப்படி எனக்கு ஸ்கூலில் உதவியாக வந்து சைன் போட்டு சரி
தேங்க்யூ. From this regular testing, we got an idea from the deaf and dumb students. They asked doubt to ourselves, like we are traveling in a bus, we want to wear a helmet and ask for the ticket to the conductor. It feels some discomfortability, right? They asked this doubt to ourselves, so we so we updated for portability to make it as a mobile-based application, mobile-based camera application. That is our prototype 2. Step 5. This is our prototype 2. Pocketable Sign Language Translation System. The updation for the portability. The voice impaired person have a one mobile-based camera application. When he kickstart the application and place in the shared pocket, it automatically turn on the camera and detect the hand sign. We can use to kickstart the application using NFC or RFID tag or codes. It feels more portability and user friendly. This project introduced the Pocketable Sign Language Translation System, where a mobile phone replaced the cap for portability and easy to use. Placed in the shared pocket, the phone camera captures the hand sign and process them using machine learning and translate them into the spoken words in real time. It feels portability and easy to communicate with a normal person. So the system introduces portability and Pocketable Sign Language Translation. The word referred to Pocketable Sign Language Translation from this prototype. This is the working model of Pocketable Sign Language Translation. You can able to see the phone's mobile camera. It's on and captures the hand sign and make voice for the sign. You can use the external sound speaker for louder sound, or if the mobile speaker is louder, you can use it. Implementation process in mobile phone in shared pocket. We'll go through the video section for scenario 5 for this working model of Pocketable Sign Language Translation.
Nandri. Valve you pal. I want medicine.
For portability, we updated the process implemented in mobile phone. We can show the sign means the phone camera automatically detect the sign and give voice for them. Regular visiting, progress and testing to shaping our product. This is the school of the Florissant Xavier Higher Secondary School for Deaf in Nepalanote. We visit regular to shape our product and we get more updation from the students about their ideas. Gesture capture to voice translation, output workflow, capture, pre-processing, future extraction, audio test output, translation, sign to voice. Now the prototype 1 and 2 work process in sign to voice, captures the hand sign and make voice. But in prototype 3, we add voice to text captioning along with that to enable bilingual communication system in prototype 3.
Choose the familiar language. Here I am a normal person. When I start to speak, it converts my voice into text. India is my country. All Indians are my brothers and sisters. I love my country and I am proud of its rich and varied heritage. Then I choose Tamil language. கற்க கசடர கச்சவை கச்சப்பின் நிற்க அதற்கு தக. It will be understood by the voice and purpose.
We first think about the voice to sign, but it feels little bit difficulty to do with the technical procedure. So we enable voice to text captioning. It introduced the bilingual communication system. We can able to see this is a voice impaired person can speak up to the normal person using the sign to voice. He can source the hand sign and make it voice. It can understand by the normal person. This is enabled in the prototype 1 and 2. For this setup, we can add voice to text captioning. The normal person make a voice. He can read with the text captioning in a mobile. This system supports both sign and voice to text conversion. The pocket mounted camera captures the signs and translate them into speech. The wristband mobile display shows live caption with the video in the pocket mounted camera for spoken voice. We can show the text captioning in the mobile wristband display. So it enables the bilingual communication possibilities. This is the working model of bilingual translation device. The pocket mounted camera in the shirt, it captures the hand sign along with the opposite person reactions video. This is the wristband mobile display, shows live caption with the video. This is the caption. Opposite person speaking, it analyzes with the text captioning and converting sign to voice and voice to text translation using pocket mounted camera and wristband display. This is the full working process of the system. Pocket mounted camera, hand sign, pocket mounted camera detect the hand sign, and wristband mobile display shows the caption. First, voice of deaf person to normal person. How the communication along with this? Deaf person to normal person. The chain. First, the deaf person capturing the hand sign. The camera, CN and instruction for future instruction, long short-term memory for gesture recognition, and text to speech engine voice output. Hearing. This is sign to voice. The voice was heard by the normal person. Fine. In the opposite reaction, the normal person make a voice input, pre-processing, ASR model in deep learning, and test output, and caption display in the screen AR overlay. It can be read easy by the deaf person in a mobile wristband display. This is the hardware setup of the process. The camera, live video to wristband display, and make sound for the voice output, and mic enabled for the normal person can able to speak. This is the wristband display. We can able to see the text captioning with the live video of the normal person. So we enable bilingual communication system with this setup. We can first travel with the prototype 1 and 2. We can communicate it with the deaf person and a deaf person to normal person, but this system enable communication between deaf person and to normal person and normal person to deaf person. Just we go through with the video section for the scenario 6, working model of bilingual translation device.
Hi. What's your name?
My name is Maharaja.
How are you?
I am fine. I need water.
Area rains heavy rain, so I got late to college. I reached college slowly.
In this progress, we listed away the bilingual translation system. In this bilingual translation system, we can easily handle from sign to voice as well as voice to text. In the sign to voice, we can access the camera to hand sign. It can convert the sign to voice. For like the bilingual translation, we can enable the her voice to my hand as a text caption. We can read it in a mobile phone as a caption with her AR/VR video. We can see the sign to voice and voice to text captioning, the enable bilingual translation system in the prototype 3. Algorithm implementation in the sign to voice system. Implementation of algorithm in the binary rules. For example, one can be defined in 10 ways. Just hands with the 10 fingers, one can be shows in a 10 ways, like 0 0 0 1 0 0 0 0 0. It stores one word. 0 0 0 0 0 1 0 0 0. It stores one word. Like we can source 1 means it's that stores 10 words. Like that, we can store 1023 words. Apart from this, we can using the case jump statement, like hold 5 fingers to jump to the case 2. Like we enable the infinity concept. We test the infinity concept means you can use infinity counts of words. So for this setup, we enable the 1023 words for 1023 signs. This algorithm setup, we nearly fetch to the Indian Sign Language, one-hand language. Technical details. Components: camera captures the hand sign and gesture, speaker output the translated spoken words, processes run image processing and machine learning algorithm, battery provides power for the some external devices like some of the wristband display, and functionality: the image processing analyze the captured hand sign, and machine learning interpret the sign using pre-trained model, text to speech convert interpret using the spoken words. For audio, we can using the PyX3. For camera access, we can using the OpenCV for camera access. Our drawbacks and demerits and innovations. Real-time gesture recognition. We regularly updating the gesture recognition using the CNN convolutional neural networks and long short-term memory. Apart from the random forest, it may smooth and very faster. We updated regularly. Utilize the advanced image processing and visual learning to instantly interpret the hand sign and providing immediate spoken translation. We regular updating the gesture recognition for fast and smooth translation. Next, seamless communication. Converting sign language into spoken words through the integrated speaker, bridging communication gap between voice impaired individual and those who don't understand the sign language. For the seamless communication, we start the sign to voice and voice to text captioning to enabling the bilingual communication system in the prototype 3. Wearable and user friendly. We designed a 3 prototype system. First one is cap, second one is mobile phone camera, third one is the wristband mobile display. Designed to a comfortable to the user to enabling the wearable and user friendly system. Our innovation in AI implementation, for like Google Siri, Google Alexa or Apple Siri, for the system we can enable one AI setup. Not we can fully enable with the AI setup because it feels like a fully AI, not by the human behavior. So we have one button, just an idea. We have one button to enabling the common questions like who is the father of computer, or some of the mathematical illusions like 2 plus 2 is equal to 4. Some of the common questions we can answer using this AI model. Who is the father of computer means there is one common answer, right? Charles Babbage is the father of computer. 2 plus 4 means it's a common answer like 6. Just a common answer enables using this AI. it can save the time and the correct answers fine. Apart from this, some of the human-centered emotional answer, it can using the hand sign and convert them into the voice. This system enables the system. The research done so far: literature review, pattern analysis, prototype development, user need assessment. We can develop the pattern and the journal for this project.